So just let me. Okay. Hi everyone. Thank you so much for tuning in. It is a kind of great pleasure finally to have Gian on this meeting. So he gonna give us a little bit information about xShape. The topic is gonna be more excited. So we are interesting to know more about the 3D experience platform, and he's the right expert for that to get kind of good information about how to the best practices for that. So I will give you the floor. Feel free to.
Awesome.
Yeah.
Well, thank you for that introduction, Mohammed. I want to try to keep today as engaging as possible. So I found this tool online called Mentimeter. It's basically like a kind of a dynamic slideshow, and it allows me to ask questions. So if you have your phone handy, you can scan the QR code, or if you want to just pop open another tab of your browser, you can just go to menti.com and then type in that 8-digit code.
Yeah.
Either way will work. And then we'll use this just to ask a couple poll questions, and we're gonna actually play a little game at one point.
Okay.
So go ahead and scan that QR code to join or use the code. I'll give everyone a minute or so to jump in here. Beautiful. And yeah, you can press this little like thumbs up thing down here. You're in to let me know that you're there. And you're out of Texas, right, Mohammed?
I was in Texas. I arrived yesterday here in Ames, Iowa.
Okay, wow.
Yeah. Yeah. So
Nice.
traveling a lot.
Yeah.
Yeah.
That's good. It gets tiring after a while, a lot of travel, but
Yeah,
it's fun.
it's kind of like exciting seeing, all of them related to Solidworks stuff, robotics competitions.
Right.
And after a week from now, I got also involved with co-experience, if you heard about it.
Yeah.
Yeah,
Yep. Co-experience.
the Dassault system engagement one. So it's kind of cool though, I have been participating in the last year in Miami. So I think it's
Beautiful.
kind of cool experience to learn more about the other branches, Innovia stuff, Simulia and others.
I wish I was there for the one in Miami last year. That's actually where I'm based out of now. I
Mm.
was up in the SolidWorks headquarters up in Boston, but just recently moved down here.
Mm. Yeah, to Florida.
Yeah.
Yeah.
Yeah, Florida.
Yes, it's kind of like a nice place, but it's kind of expensive though. Yeah.
Yeah, it's expensive. A lot of
Mm.
crazy people here too,
Yeah.
but it's good. It's good. All right. I think we got enough in here. And keep in mind when we move forward, if you want to join at any time and you miss the QR code, you can still go to menti.com and this code will still be here at the top if you'd like to join. So thanks for showing up today. So the first thing I wanted to talk about is just kind of like what is XShape, and really before that, how often do you guys and girls and everyone on the call, how often do you design things that include complex shapes or surfaces? Like, is it something you do daily, weekly, monthly, yearly, or is this something that you kind of rarely do, like almost never? And okay, so it looks like we got a few. So a lot at monthly. Wow, we got one daily surfacing user. Awesome. That's good. Great to see. Yeah, and any type of product would fit into this category that includes like those complex shapes and surfaces, like a bike helmet. It could be something, in aerospace that has those crazy surfaces, or it could be something more like a consumer product, really anything in between. All right, awesome. So we got a couple of answers there. It looks like we have a good mix, but it seems like almost everyone has some familiarity with designing complex shapes and surfaces. So when it comes to X-shape or sub-D modeling, I'm wondering, who have you heard of X-shape or have you heard of sub-D modeling? Do you have an idea of what it is, or not? You know? Okay, so if you have never heard of it, that's great. That's great. Because we're going to start from absolute basics today and And if you haven't already joined, be sure to go to menti.com and type in this code so that you can join this, because we're going to play a little game in a moment. All right, cool. So it looks like, about a third have heard of it before and some have not. So I'm going to jump over to show a couple. Okay, so a lot haven't actually heard it. That's great. So let's take a look at what actually is sub-D modeling. And that's kind of the three things I want to touch on today with complex surface design with xShape. One is, what is sub-D modeling? And that is what we're going to start with. And then we'll talk about using xShape in Solidworks, and then, kind of the beginning of an advanced topic, parameterizing sub-D. But first, what is sub-D modeling? Well, sub-D modeling it's not the same as parametric where everything is feature based. You're kind of starting with like a digital hunk of clay that you can set parameters for, but then it's really just pushing and pulling to get the different shapes that you want. There's no feature tree, so you'll notice that like we just have one subdivision surface here that we're working in. There's no new features being added, but we can just kind of sculpt this shape into the form or into the surface that we're looking for. And there's a lot of really, really interesting options along the way that make this a really useful tool for mechanical engineers, industrial designers, and a lot of mechanical designers and product designers that have a need to create things that are complex in nature, at least in the exterior surfaces. So there's a whole host of different products that can take advantage of a tool like this. But I actually want to take a step back and actually show the main types of products that we deal with as SolidWorks users. If we put them all in a spectrum, SolidWorks might find its way into every single one of the products that you see on screen right now. But we tend to think more in the mechanical design realm. That's where we focus. That's where our strong suit is. And of course, we have incredibly powerful surfacing tools. But then once you get to certain areas like artistic design, this is when a lot of companies, a lot of industrial designers and product designers use mesh modeling tools, like you might have heard of ZBrush or Maya or Blender. Like those would be mesh-based tools where you're creating a mesh, and it's a lot easier to be artistic because everything is not inherently constrained with parameters the way that mechanical design is. But industrial design is somewhere in the middle where there is an artistic portion of it, but then there also is some mechanical design required too. And that's really where xShape tends to shine. So xShape is our actual sub-D modeling tool that is fully on the cloud, fully in a browser, but it works really well with SolidWorks, and we'll show that in a moment. But the difference of what comes out of this. So I mentioned how on the right side of the spectrum here, you would typically use like a mesh modeler. On the left side, we need to end up with what are called NURBS surfaces. So there's two different types of formats. There's NURBS, which are non-uniform rational B-splines, and this is what SolidWorks surfacing creates. So SolidWorks surfacing, it's creating these surfaces that are driven by math and geometric constraints and relations, but still give you that smooth result. And the native CAD system like Parasolid, we got SolidWorks, NX, Solid Edge. CATIA uses the CGM. There are different, I guess, underlying technology that produce the surfaces, that produce those NURB surfaces. Whereas mesh, like we see on the right here, there's a few different types of meshes, but there's a lot of different tools out there for making mesh models, like I mentioned before, for the more artistic side of design. And these are what are called tessellated. So they're not always inherently smooth surfaces. And if you've tried to use mesh data in SolidWorks, then you probably know that it doesn't always come through perfectly the way you want it to. And sometimes you need to do some post-processing steps to get that the way you want it to look. So subdivision is kind of in the middle, where subdivision, you're starting with a mesh. Like you see, we have this kind of cage or mesh of vertices and lines connecting them, but then we also have the surface in the middle. So we are actually using a control mesh That's what we're using to create the shape. The resulting surface, it has no concept of the shape. It like you can make a circle or a cylinder in sub D. It doesn't actually know it's a circle or a cylinder. And as soon as you were to like push or pull one vertice or one vertex rather, then it's no longer a perfect cylinder anyway. But you get this extra flexibility. So in order for what we make in a subdivision tool to be used in a normal parametric assembly, like if you wanted to make this Orca in xShape and then bring it into Solidworks, we still need a NURBS surface. And one of the really powerful things about xShape is it allows you to model freely in this subdivision environment, but then as soon as you're finished, it converts it to a NURB surface automatically so that you can cut a hole through it. You can use other traditional surfacing tools. You can do whatever you need. So the NURBS, the non-uniform rational B-splines, that's where everything is driven by math. And we kind of get the best of both worlds with xShape because you can model things in sub D and take advantage of the speed and the freedom that it gives you, but still end up with usable surfaces in SolidWorks. So I'm going to jump back, or actually, you know what? Fun fact first, before we jump back, is that sub D modeling was actually invented by these two guys, Edwin Catmull and James Clark, for Disney, for their own character development. You know, they created this tool called Netscape, and they still have Disney, I believe, still has their own proprietary software tools they use to model their characters as well. But that's kind of where it all started, and it blossomed into a bunch of other products being included as well. Um, the, and the key benefits are shape creation without any overhead. You don't have to create sketches. You don't have to create, you don't have to have a plan in mind. You can start right in 3D. There's less of a hack and slash method to make changes because when you're making changes, you're just pushing and pulling either the vertices or the faces or the edges on the sub D surface. You're editing a single shape. You're not actually editing a whole list of features or series of features. The results are always smooth and it's G2 continuity. So the highest level that most industrial designers or artistic designers are looking for in their surface design. And it's just easy to learn. It's really not an incredibly difficult tool. There's not a ton of features because you don't really need them. You have a select set of features that can kind of allow you to make almost anything. And when to use it, the best time to use it is concept creation when you're doing that primary surface design before you do, you know, all the features downstream. And then, of course, whenever there are reduced constraints. So there are always going to be parts of your design that they have to constrain in some way. They have to be, you know, a certain dimension wide, or they have to, you know, interface with another component in this specific way that is constraining on the design. But when that's not the case, you know, that's where xShape is very, very powerful. Okay, I just saw in the chat that there's no sound. Are you guys still hearing me?
Oh, yeah. We
No.
can hear
Okay.
you. Yeah, you got
Okay.
probably internet connection problem. Yep.
Okay. Awesome. All right. Just wanted to make sure. Thank you. Okay. Now, I promised we're gonna do a game. So if you just joined late and you haven't already joined the Menti, go to menti.com and use this 8-digit code, and that way you can participate in the game with us. So if you don't have this up, switch back over to this tab. We're gonna play a little game called Sub D or Surfacing. So the rules of the game is that I'm going to show you a model and I've homogenized all the images of the model. So it's not like a screenshot from within SolidWorks. I've rendered them all out in the same system. So you just see a product and you're going to choose, do you think that this was made with a sub D modeling tool or was it made with traditional surfacing? Okay. And I didn't make every single one of these, but I have made almost every single one. All right, let's get started. So first one, this should be an easy one. This computer mouse. Is this one, do you think, what does your gut tell you? Was this made in sub D our subdivision tool xShape, or was this made using traditional surfacing from Solidworks? And if you've done some of the SolidWorks surfacing training, then yep, it seems like most of you do have the right answer. That this one is 100%. That one is surfacing. And that's one of our SolidWorks surfacing tutorials right there. All right, let's do another one. So this hook, right? I think we might have seen this maybe in another tutorial somewhere else. But what is this? Was this hook made with surfacing or with sub D only? So it looks like, so three think it's surfacing. All right, so the majority definitely thinks it's surfacing. Yeah, Ben definitely thinks it's surfacing. One for sub D. Okay, awesome. Well, our single voter for sub D was actually the one who got it right. This one was made in sub D. So just to show you that not everything you see that looks very parametric in nature is actually only done with surfacing. There's a lot of ways that you can accomplish shapes like this with xShape or with the subdivision tool. All right, what's next? This water bottle. What do we think? Is this one sub D or is this surfacing? Surfacing. All right, cool. Everybody thinks this is surfacing. Yep, you got that one right. This one was surfacing. This is actually from a SolidWorks surfacing tutorial on YouTube. If you haven't seen this one, it's a pretty nice one. All right. Let's go to the next one. This kayak. Is this sub D or is this surfacing? Sub D instantly got 3 votes. Wow. Yeah, you sub D voters, you got it right this time. This one is definitely sub D. Although you could have just, maybe not just as easily, but you 100% could model this using traditional surfacing tools. And that's probably how most kayaks are modeled. They're probably not modeled in, for the final version using sub D. But all right, this football helmet, sub D or surfacing. What do we think that this one is? Sub D. Wow, a lot for sub D on this one. Tough because this one is actually only surfacing. So this was surfacing only. But you definitely, once again, could model this in sub D. All right, motorcycle helmet. What do we think this is? Sub D or surfacing? All right, instantly we got a bunch of votes for sub D, and you guys are all right on the money. This one is 100% sub D. But again, a lot of what you see here, or at least I shouldn't say 100% sub D, because the base of this was made in sub D, and the base of pretty much everything you see here is made in sub D. But then we did use a couple surfacing features to clean it up and to get it looking the way it looks here. And that's just to paint the picture that like you're never going to only use one. Sub D is really just another tool to add to your arsenal. It's another tool to add to your toolbox of things that you can use to, create quick concepts, create the base surface, and then, add whatever features downstream, surfacing or not, to get it ready for manufacturing. All right, either last one or second to last one. What do we think this one is? Yeah, this is an easy one. This one is 100% sub D. This was a really fun one to model. This is one that I worked on with a colleague of mine. This was great. Yeah, 10 out of 10 out of we got 10 votes for sub D. You guys are right on this one. What about this one? This is another really artistic one. And immediately it seems like everyone assumes that this is sub D. But you might be surprised to know Jordan Tadich, if you know Jordan, he actually modeled this in sub D sorry, not in sub D, with SolidWorks surfacing. And he actually told me this took him roughly about like 40 to 50 hours or so to model this thing using traditional surfacing tools. All right, last one, wolf head. At this point, we've shown you a bunch of complex stuff that is sub D and surfacing. So Could be hit or miss. I don't know. What do you guys think? Yeah, everyone thinks that this one is sub D for the most part. And you guys are all right. This one is sub D. My last question, though, for you all, this is still part of the game. I'm curious. You know that this wolf head was done in sub D, but how long do you think that it took for me to model this in sub D? So you can use this slider to choose like where is it 1 hour? Is it 50 hours? Somewhere in between. How long do you think that this actually took to model? And keep in mind, Jordan's his little Santa head took about 40 to 50 hours to do it using traditional surfacing tools. All right, and it seems most of you think that I am like a sub D genius and just modeled this in 1 hour. It did take 3 hours. So it looks like a couple of you were right there or very close to it. And I have proof because this was all done in actually one modeling session that I just recorded on my laptop. A lot of the time lately, I've just been like recording everything I do in sub D. And then because I love kind of watching the time lapses after the fact, kind of see how I actually figured out how to model this thing because it quite literally is just like pushing and pulling a blob of clay. Like you add material, you take material away, you want to add more or less detail, you subdivide or insert more loops, making this tongue was really interesting. And then making the gums here. This is a really weird way to make the gums, but they're all just separate sub D bodies. And then making each individual tooth, they were each their own sub D body here. Luckily, we have like a copy and paste sub D. So I could just like copy the tooth and push it over, change it a little bit, make it a little bit bigger or smaller. Yeah, this nose was pretty interesting. And this is super fast. This is 68 times speed, times like the normal speed. But yeah, this is a lot of fun, actually. I'm sure that you guys get into this state of flow when you model in SolidWorks, when basically like you're having more fun than you are actually like putting work into modeling. And so it doesn't even feel like you're really working. That's kind of like how it is for me with xShape. I love this kind of digital sculpting that we can do here. So I think that that just wraps up about about the wolf head itself. Um, yeah, we did add a lot more detail after the fact, but you can see how quickly we were able to get to a shape that was usable. And just for your reference, this was I don't just model wolf heads for no reason. This was for a magic wheelchair project that one of our kiddos over in the Detroit area was a big fan of wolves. So I was the modeler for one of the teams working on one of these magic wheelchair projects. If you haven't heard of Magic Wheelchair, it's this amazing foundation where they find kiddos with wheelchairs that have like a particular interest in having like a really cool wheelchair that they get to choose what it is. So I got to play a small role in this really, really cool one where this kid loved wolves. So we got the heads like 3D printed and we had a lot of help getting this whole thing together, but this was a lot of fun. All right, so that was kind of like what is sub D modeling at a high level. Um, I want to show what's relevant, what's most relevant to you all, which is using xShape and SolidWorks together. So like, what does that actually look like? How would you, as a SolidWorks user, be able to take advantage of a tool like this? Well, there's two primary methods. There's using it in assemblies, which is one method, and then there's when you actually have an X-shaped surface that you want to add features to in SolidWorks, and that's when we use the second one when you want to use X-shaped geometry in SolidWorks parts. So let's say I have an X-shaped component, I want to drag and drop it into SolidWorks. I instantly am prompted with a choice. Do you want to make this a 3D experience component that'll just be added and it would turn your SolidWorks assembly into a multi-CAD assembly where you have SolidWorks parts and 3D experience components. The other method is create a new SolidWorks derived part, which basically it automates the process of creating a new SolidWorks part and then doing like an insert part feature of the 3D experience component so you can keep adding features downstream. So we'll take a look at both of those methods. I love modeling right in context of the assembly. So one of the things that you can do in the X apps and in xShape, we can insert components right into the SolidWorks assembly so that we can actually sculpt in the context of our assembly itself. So just like you saw before, we can sculpt this gaming controller into shape. I'm going to fast forward through most of the steps here. We can apply symmetry, we can crease, and we can save and then propagate these changes back to the SolidWorks environment, right? So we'll save, and then we're just going to simply reload the assembly from the server, right? And this works because all of our data, all of our SolidWorks assembly and parts here are stored in the 3D Experience platform. So if you're not familiar with this little task pane on the right, this is the task pane you get when you save everything to the platform, to the 3D Experience platform. And then this right click and reload from server allows you to just look back up to the cloud and pull down the latest version. And then we see we get loaded up with the new assembly that includes this controller shape 3D experience component. But what happens when the SolidWorks geometry changes? So for the example of this gaming controller, maybe our joysticks end up being a little bit bigger at the base there. Once again, all we had to do was reload in xShape, and we can see those changes propagate immediately. But what happens when the xShape geometry changes? Well, it's a very similar method. In this case, we're just going to pull this face forward a little bit so we don't have to compromise our shape. And then once again, in SolidWorks, we're just going to save and reload from server. And now we can see we no longer have that bleed through. And if you tried to do this with SolidWorks surfacing, I'm sure it might not have been the most painful change to make that you could have had to make, but this one, it's definitely going to be faster using the sub-D method in this case when you're still concepting and everything versus if everything was defined with splines and sketches and surfacing features. It's just easier to make changes. So this is where I'm going to switch over to the second method. So far you saw the multi-CAD approach. So you can have the xShape component, which is a 3D experience component, live inside of a SolidWorks assembly. You can mate to it. You can add whatever features in xShape and XDesign to prepare that for manufacturing. Like you can shell it, you can cut the holes through it in XDesign and xShape. Or if you would rather add those features in SolidWorks, what you can do is create a derived part from the xShape component. And all this does is automate the process of creating the part and then inserting the 3D experience component inside, maintaining that reference to the xShape part. So it's very similar to like what I mentioned, an insert part. So you know how you can insert a part within a part. Oh, that's very common when you're as industrial designers, if you have like a base part, like an overarching shape for the product, and you want to split it out into sections, then this is a very common way to do it. And in this case, our insert part is just of a 3D experience component. So in SolidWorks, we can add features like we can shell, we can use the indent feature. I love the indent feature. So powerful, especially when modeling like in the context of an assembly. We can add those kind of features. And then what happens when the xShape geometry changes though? How do we actually propagate those changes back down? Well, we can still just save and reload from server. The process is the exact same, whether you're using it as a multi-CAD assembly or whether you're using it in this derived part method. So that was a lot going on right there. If you have questions, feel free to throw them in the chat or just unmute and feel free to ask. But this is the basics of how you would use SolidWorks with xShape, using those two tools together. And remember, xShape is fully on the browser in the web interface. I usually will have, you know, xShape on one screen and SolidWorks on the other when I'm using a lot of design, when I need to design with both tools. But that's the extent of using the xShape geometry in SolidWorks assemblies, as well as using that xShape geometry within an actual SolidWorks part. So just to recap, SolidWorks assembly that includes the 3D experience component versus a SolidWorks part that references the 3D experience component. So you the one on the left, so the using it with assemblies, this is the multi-CAD assembly approach, whereas the other one is the SolidWorks assembly with some parts that reference 3D experience components. So there might not be a 3D experience component in the tree for your assembly, but some of your parts will be pointing to that. So for the assemblies, you can just insert a new 3D experience component in SolidWorks or in xShape and start modeling right in context. Whereas in the SolidWorks part approach, you're actually going to insert the 3D experience component into SolidWorks, or you can jump from one of these methods to the other, which is what we did when we created that derived part. So you can start using it as a multi-CAD assembly. And that's really my recommendation is like, if you're working on a product that say has a bunch of mechanical internals, and then you have some swoopy shape or some industrial design shape that needs to encompass the whole thing, I would always model that as a multi-CAD assembly, get the surface as far as I possibly can to being complete before I add any manufacturing details. And then you have the choice. You can add those details in XDesign and leave it as a multi-CAD assembly, or you can, you know, follow this green arrow and transfer it into a derived SolidWorks part. Sorry, question? Oh, just thought I
So,
heard some
yeah.
background noise.
Yep.
Okay. All right. And so why would you do the left side, the left-hand method, the multi-CAD assembly? Well, because it allows you to complete all the component design for xShape components within xShape or the xSaps. You know, it allows you to just kind of stay in one environment for some components and one for another. Okay, so it looks the question is what is sub D? Didn't really get it. So sub D is it's what we did a little bit earlier here. I'll go back to so sub D is this tool right here, basically where we are pushing and pulling vertices and edges and faces rather than to end up with a shape rather than having to like define a sketch with splines and profiles and then use surfacing features. Instead, we're able to use this system where we can just subdivide, we can insert loops, and we can just kind of push and pull the different edges that we need and add creases wherever we need to end up with the shape. So just jumping back to where we just were. All right, so that just about covers this. All right, but the why you would use the SolidWorks derived part method is because you want to use SolidWorks features. So if you can get what you need to get done using xShape and xDesign for those components that like use xShape, great. If you need SolidWorks for some of the advanced features we have, like whenever I need to do anything injection molding related, I don't know if I could live without the lip and groove feature, the mounting bosses. You know, we have some really powerful ribbing in SolidWorks and a bunch of other tools that are great for injection molding. That's when I would say, okay, take your X-shape surface as far as you possibly can until you're happy with it. And then let's bring it into a SolidWorks part and add whatever features we need to downstream. Right. And that is the basics of using xShape and SolidWorks together. So let's jump into, unless there's any other questions, feel free to throw them in the chat or unmute and ask. But the last thing I wanted to cover today was Yes, yeah, great question. So yes, sub D is like working with clay. It's like working with a hunk of digital clay. There is inherently less constraints, less parameters, but the last section I wanted to show you today is called parameterizing sub D. And I wanted to share that because it's one of the first things I always get asked by SolidWorks users is, okay, if I make this surface in xShape, how do I make sure that it is the correct dimension? How do I make sure it's accurate and lines up with what I need it to in the assembly? So I have two models to look at here. We've got the hook, which we now know is made using xShape. And then we also have this cool roller coaster part where I think it's the lap bar that we're going to take a look at. But let's start with let's start with the lap bar. So, or the restraint system, I guess, for this roller coaster. So this is just one context of an assembly that we had to fit parameters of other components. So in this one, I'm going to fast forward through most of this, except for the parts that are really specific to this one topic, right? So we start with this blob of clay. We're pushing and pulling, and we're adding symmetry, inserting loops. We can extrude faces and add creases. And one of the things that we can do is crease outer edges to define a flat face. So you'll notice that in sub D, we have all these different faces. And as long as there's creases all around one of them, you can actually make it fully flat. And both xShape, XDesign, SolidWorks, they'll all recognize it as a flat planar face. And then we can do things like align it to other flat faces. So we can take that flat face we just defined in our X-shaped surface, and we can align it to geometry so that we can make sure that this actually fits where it needs to. So we can keep using those alignment tools to get this to the right dimensions that we need it to be. Another thing that we can do is align edges to be collinear, right? So we can align all of these sub D entities to each other or to other model items that are happening here. And then once again, we can just sculpt whatever we need to sculpt. We can just make whatever shape we're looking for, mostly just by pushing and pulling with this little robot manipulator. This little the little like triad that we call the robot. You'll notice I have creases going all over this model, those like pink edges that kind of break up the continuity of our surface, which is just a real time save. You know, it wouldn't be as useful of a tool if you could only create like super swoopy shapes. Sometimes you need like hard edges in there. Flattening faces. So we got a bunch of facets that are all kind of doing their own thing here, but we want to make sure that they're actually flat. So we can grab all four of those and align them coincident. So aligning them coincident that actually makes them flat relative to each other. And then we can just continue modeling here. I hope that this isn't too fast for you guys. I know I kind of keep it fast because I don't want to show things twice, but I also love the kind of time-lapse approach to showing X-shape because, you know, I could model something live for you right now, and we could get like maybe 10% as far as we see right here, but we won't be able to see the entire thing. So another thing that we can do that becomes so powerful is being able to translate along a direction that is in the model itself. So like we can set our robot to now go along that edge in the model and then make translations or make manipulations to the model that are in line with that direction. You see, I've done a ton of different just like working and reworking. It's very conducive to the creative process, you know, where you're kind of figuring out what shape you might want to use. And it's gotten to the point where I barely sketch anymore. I don't really do much 2D sketching when I want to make something. You can just jump right into 3D and just kind of figure out what the shape is that you're looking for. And you might have seen that I was jumping back and forth within that cage view where you kind of see the mesh. That's another really useful tool in there. But that's how we can take advantage of the designing in the context of an assembly where there's a bunch of constraints. We needed to make sure that the lap band had certain faces that would align to the edges of our restraint system, that would align to those outside walls. We also needed to make sure that certain edges or certain movements that we made were only along a certain direction, and we can set that direction based on the other parameters in our model. And then we also saw a bunch of alignment tools that you can use to flatten faces and make them work for what you're designing. All right, now we got the hook. This hook is the last model we're going to see like from start to finish, but it's got a lot of really interesting tools in here that just prove that xShape can be used on parts like this that include portions that you do care about, like the math driving behind it, but then maybe you don't about others. Like for this hook, we would want to make sure we have a minimum thickness going along this, and we would want to probably run some simulation or do some back of the envelope calculations to make sure that the hook is not going to fail based on like the thickness that we use and the shape and everything. But a lot of that can be figured out regardless of what the dimensions are. There's only a few places in this where we need everything to fit a specific dimension. So one of the tools that we can use is the extrude, revolve, or net surface. So you can use a sketch to actually define the sub D itself, that sub D surface. But keep in mind that it's the cage that we're working on. So the cage itself is what we see going around this grid of faces and edges, but the surface within is what we actually end up with. And we can revolve, we can extrude, or we can loft and sweep to get our starting surface. And we can like edit the number of edges going along this thing till we get the right number of vertices or faces that we're looking for. And then the first thing I do is crease so that we can end up with flat faces everywhere. And then we can make precise movements. So you might not have realized this, but this robot manipulator, we can move it by exactly 5 millimeters, or you can type in an exact value. Now, the thing to be aware of is you're not going to end up, unless it's a flat face, it might not matter. But if you need to have two flat faces that are parallel to each other that are, say, 20 millimeters apart, you can still accomplish that with the sub D modeling in xShape. It would, yeah. So you can still get there, and there's still plenty of other places too that we can do the same thing. But let's actually delete these faces. So we want to connect this one sub D to the other, right? Because we want to merge these two together. So I just deleted those two faces, and now I'm going to extrude the edges of the surface and then just kind of line it up loosely where I need it to be. And then one of the newest features that actually just came out a couple months ago is called the Merge Sub D Surfaces tool. And this is an extremely powerful tool where you have two separate sub D surfaces and they both have like an open area. And we're just going to connect those open areas together and end up with one final subdivision model or one final subdivision surface. And now we have one subdivision surface that we could actually make sure was exactly 60 millimeters in width. So we can generate exact dimensions between flat faces. Now, the tough part is right now, it's not, there's no easy way to ensure that dimensions of circular, cylindrical edges or faces meet an exact radius. And it's very difficult to get the curvature, like the way that you can define a spline, how you can say, all right, if I have a bunch of different spline points, I can make one point, I can make 1 point, dimension a certain value away from another one. And although you can kind of get that to work here, it's not the same because remember, there's the cage. The cage points are what we're actually defining the distance between. And when it's flat faces, then the cage is the same as the surface. When they're not flat faces, the surface is being interpolated from the cage, from that mesh of points and vertices, faces, and edges. And that's when the surface isn't necessarily on the vertex. It might be slightly inside or outside of it, depending on how the math works out. But the thing we do know for sure is that using flat faces with sub D is foolproof and does work. You can get the dimensions that you're looking for, not in the traditional way that you would like adding a dimension in a sketch, but you can still accomplish the high level of precision that you might need for flat faces as they relate to the rest of the surface. And then, of course, we can still cut things. We can still cut through this. We can add fillets. Um, we can just add whatever other manufacturing details we might need. And then maybe we change our mind and we don't want this to be flat across the bottom. We can push that up to the top and actually get that to be up by another 4 millimeters or so. We can push those faces up, and then the rest of our parametric features downstream will all update accordingly. But let's say I want to turn on what's called the working zone so that I don't edit anything else. So I'm going to leave the top alone while I mess with the bottom, while I mess with the hook itself, and now the rest of my features are still updated the way that we would expect. And yeah, that's the basics of how you can use the working zone to make sure that you don't edit anything unnecessarily in the subdivision surface. And yeah, we added a cut, we added a couple fillets, and you could design this part fully in XDesign. Again, if you wanted to add those features in SolidWorks, you could bring this into a SolidWorks part and add them there just as well. So that was just about it for making your sub D fit certain dimensions. All right. So we saw two methods where we wanted our hook. We had certain dimensions we needed to apply to our hook. And then in the assembly, we might not have necessarily cared about what the dimensions were, but we needed to work our surface around the parameters of our assembly. We needed to make sure that that lap bar could actually fit on the restraint system and, be possible to actually attach that thing. So those were two great examples of parameterizing your sub D, parameterizing sub D geometry. The last thing I just wanted to share is how to get xShape. Basically, if you're interested in trying out xShape, there's 3 ways to get it professionally. But the main thing is to talk to your reseller about it if it is something that you're interested in. There's 3D Sculptor Roll, which includes just xShape. And if you have SolidWorks desktop already, this is probably the easiest way to get your hands on xShape. If you are using 3D Experience SolidWorks, or if you've heard of 3D Experience SolidWorks, it is the same SolidWorks that we all know and love, but it is now installed from the 3D Experience platform. It actually makes the installation process so much easier and the upgrade process. We just had an upgrade on Monday and I updated SolidWorks. It was done downloading and installing in about 20 minutes, I want to say. I was back to work on the latest, greatest version of SolidWorks, but that's not what I wanted to talk about regarding 3D Experience SolidWorks. The reason I bring it up is because Professional and Premium actually include xShape already. So if you had one of those, or if your company has one of those, definitely take advantage and ask your CAD admin or talk to your reseller about getting your hands on xShape in that way. And then, of course, SolidWorks Cloud is the last option, and that includes a whole host of web-based CAD tools. xShape is just one of them. I mentioned XDesign, and then we have a bunch of other specialized ones for sheet metal, weldments, structures. The list goes on. If you wanted to try this, and I don't have this on the slide, but if you wanted to try this on your own as a maker potentially, that is actually the lowest barrier to entry that I find. And I actually have a maker's license myself just because I want to be able to make things that are owned by me and not owned by SolidWorks. So whenever I want to do something really cool and creative, I'll use my Maker account. I believe it's either 50 for the year or it's 15 a month. And it includes 3D Experience SolidWorks Premium, which comes with xShape and XDesign, and a few other apps as well. But if you wanted to just try this out and get your hands a little dirty with the tool, that's probably the cheapest and easiest way to just give it a try, just give it a go. Um, but yeah, I guess that's the extent of how you get your hands on xShape today. The easiest would be the maker's offer if you're interested in doing it for more personal projects. If you want to talk about it, if it seems like a tool that you could use, because I know one or two of you mentioned that you do complex shape and surface design daily. I know a handful of you said that you do it maybe once a month or so. But if this seems like a tool that you could benefit from, definitely talk to your reseller about it. Feel free to reach out to me. I'll share my email in the chat here. It's just my first and last name at 3ds.com with a little dot in the middle. So feel free to shoot me an email. I just put that in a chat. Um, and I'll open it up for any questions if you guys want to talk about any of the models that we saw today, or the modeling workflow, or what is xShape. We can go back through any questions that you guys have. I am here to answer.
Yeah, yeah, it's
Great.
really nice. Yeah. I will add to that. Like I've been using the Maker Edition. This is kind of like a cool tool. And also, guys, through the swagging, you got like able to get the free version for Maker Edition through the meeting. So I'm planning to do that, to
Oh,
get
beautiful.
one. Yeah, I have been like, if you can see, like low.
Oh yeah,
Yeah,
that's awesome.
yeah. I created using the xShape. It's kind of like a cool one.
Well, I guess everybody just wants to make wolves in
Yeah,
xShape.
yeah. It's kind of like I made it. I printed for my little brother. He enjoyed it. He's now like thinking to go the same path. Related to engineering and coding and stuff.
That's awesome. That's that's great. Have you done any other xShape modeling in that, Mohammed? Have you made anything else cool?
Yeah, I got like different stuff. Participating in Model Mania, creating like a mountain skateboard, electrical one. So
Oh,
yeah,
nice.
it's kind of nice. Trying to like move to hover over the 3D experience platform is kind of like good stuff, to find all of the rules all in one, easy to shift between them. So it's really like efficient for like professionals, students, makers, all of them.
Right. No, it's definitely a solid tool for especially for makers. I find myself using it a lot like just relaxing on the couch. I'll be on my tablet,
Yeah,
just using
like
it.
I gonna actually like mention that, use it with my tablet also, it's kind of like handy thing, push and pull, 3D continuities is kind of nice. Yeah.
It's
Yeah.
definitely not. It's really nice to have it so accessible. I mean, you say what you will about having it in a web browser, but at least it doesn't matter if it's on a Mac or if it's on a PC or if
Yep.
it's on whatever device that you might want to be using. Yeah, I just like being able to be flexible. And as long as you have solid internet connection, then
Yeah. It's
it's
all
very
good. Yeah.
responsive.
Yeah. I shifted to Mac, so it's kind of like a good deal for me, using it, it's kind of easy, because the last time I have to use like kind of mirroring tools on Mac in order like to apply like some software stuff. So now it's kind of easy, no need just like internet connections, and you log in every device. It's not about like your own device.
Right.
So it's kind of easier.
That is definitely nice and easy. All right. Well, I guess we're not seeing too many questions right now, but I'll leave you with sub D modeling. is speed and freedom. As an industrial designer, as a mechanical designer, as a mechanical engineer, if you're using SolidWorks surfacing, or if you have a need to create complex shapes and surfaces, what sub-D modeling offers is speed and freedom. All right, design freedom and just being able to generate and alter your concepts, your design concepts just so much faster. So again, feel free to reach out to me over via email, and I'm happy to chat with any of you. Okay, now we got a couple questions. Can we use xShape in the mobile platform? Yep. So xShape lives on, in the mobile platform, in the web browser, in our cloud-based 3D experience platform. So you can access that on any device, on a tablet, on a Mac, on a PC, even on your phone. It might be I don't know if I could model like on my phone. I mean, I know you technically could, but I don't know if I would want to. I'll stick with my tablet. Um, playing with Callie to bring childhood memories. Yeah. Yep. It'll definitely bring up some childhood memory. Reminds me of like summer camp playing with clay and stuff like that. Play-Doh, all that fun stuff. All right. Well, thank you so much for having me, Mohammed. I hope you guys all enjoyed this. If it wasn't relevant, let me know in the chat if you have ideas or if there's something else that I can present on related to this. But yeah, that's about all I have for you guys today. Thank you
Yeah.
so much again for including me, Mohammed.
Yes, thank you so much. Really appreciate it. Your time is kind of really impressive and like informative presentation about xShape. I've been learning, by myself, also trying to figure out something new. So it's kind of cool thing to have an expert and getting more hands-on experience, tips and tricks, and all this stuff. And the perfect thing and new thing, the engaging thing that you have doing, the like asking questions, having like the people think them participating on that is kind of engaging. So it's kind of like really nice meeting. So I really appreciate it. Yeah.
Awesome. Yeah, I'll try to keep it just as engaging or more so for next time. For those of you, if you do want to learn xShape, you just reminded me tips and tricks. So a colleague of mine spent the last year or so developing a bunch of tutorials on xShape. So if you go to solidworks.com/xShape masterclass, and it like the link will change, but it's the same thing, xShape masterclass. It'll redirect you to this page that has a little highlight video of what is xShape, but then it has a bunch of tutorials, 3 at the basic level, 3 at the intermediate, and then 3 that are more advanced. And these are all available. The files are all on here. And there's an FAQ at the bottom. So take advantage if you want to try this out. If you're using the maker's license or if you're using xShape at all, yeah, this is a great way to get started. But sorry, that was one more I promise that's the last final thought that I have for today. All right, thank you again so much, Mohammed, and everyone for joining. Um, yeah, I look forward to chatting with any of you who want to keep the conversation going.
Yeah, I appreciate it. And also, guys, you're gonna find like this meeting recorded in the YouTube channel, so feel free to watch it again. It's just kind of like a good start for you to walk through the xShape. So I appreciate it all. So we'll see you the next meeting, inshallah.